All right. Hi. Thanks for watching. In this video, I'm going to go over the solutions to Worksheet 4.2. So here we go. So for each one of these, you just need to find the x and y components. So basically, you take this force, which is at an angle, and you're going to break it into the x component. So this would be the fx, and this would be your fy. Just basically making it into a right triangle. And then, right, you're going to use sine and cosine to break it into pieces. So since fx is the adjacent to the 60-degree angle, it's going to be fx is equal to the hypotenuse, which is 12 times the cosine 60 degrees, which is going to give you 6 newtons. And in the y direction, it's right, that's the adjacent, or sorry, the opposite, and so that's going to be sine. So you're going to have the hypotenuse, which is 12 newtons, times by sine of 60 degrees, which is going to give you 10.4 newtons. Okay, moving along. Next one. This one, when you turn it into the right triangle, it's going to look like that. Basically, right, horizontal part to the left, that's going to be your fx. It's going to be your fy. Same thing, fx, that's the adjacent, so you're going to take hypotenuse, which is 15, times by cosine of 20 degrees, and that's going to give you 14.1. If you looked in the solution, it has a negative sign there. Don't worry too much about that negative sign. Usually the negative signs are going to be put in when you are like actually summing your forces, so you don't need to have the negative sign in this part. So this one will be 15 sine 20, which is going to be 5.1 newtons upwards. Okay, next one. Let's see here. This one can be brought into, usually when I'm drawing my triangle, I try to go around the angle that's given. So since they gave us an angle with respect to the vertical, this becomes my fy, and this becomes my fx. Now, because they did that, my fx is actually going to be sine, because you'll notice opposite from the 30 degrees. If you wanted to use 60 degrees and kind of go that way, you could, but you would use and then it would be the horizontal would be cosine and the y would be sine, just like you're used to, but then you'd have to use 60 degrees. So I'm going to stick with the angle they've given me, and so that's going to give fx is just going to be the hypotenuse, which is 25 times by sine of 30 degrees, right? Again, that's backwards from what it normally is. You just have to know your trig enough to know that it's going to be different this time because they gave you an angle with respect to the vertical, and that is going to be 12.5 newtons, and Fy is going to be 25 cosine 30, which is going to be 21.7. And again, this is a downward force. If you looked in the solutions, it did have a negative sign there. Don't worry about the negative sign. Again, usually you would put that in when you're actually summing your forces. Last one here, this would be your fx, y. Fx is going to be hypotenuse 10 times by cosine of 15 degrees, which is going to give 9.7 newtons, and Fy is going to give you 10 sine 15, which is going to be 2.6 newtons. Again, the solutions have a negative sign, but don't worry about that. All right, let's move on to page 2 here. So now we're going to actually start trying to practice summing our forces. So, or actually, for a real problem here. So the first thing, we have a person pulls on a desk with 200 Newton force acting at a 30-degree angle to the horizontal. The desk does not budge. So we got our person. They're pulling with 200 newtons. We got our force of gravity. we have our normal force. Note that the normal force should be smaller than the force of gravity because you're supporting some of the weight as you lift up on it. And then you also have, it's moving, it's not budging, so the force of friction, it does need to have a force of friction kind of opposing your direction of motion. It then says determine the x and y components of tension. So let's see here, we'll do that next. So we got our x component here. So we're going to break that part into the x component. So this is going to be, well, just while I'm here, that's 200. Let's see here, that's 30 degrees. So that's 200 cosine of 30. And we got our vertical component, 200 sine 30. So number two, it does have us break that into pieces. I guess we'll, for the y component, which is 200 sine 30, which is going to give you 100 newtons. And the wider, or the x direction is 200 cosine 30, which is going to give you 173.2 newtons. So then it says sum your forces in the x direction. So again, we start out with that notation. Some of the, oh, I wrote y though. Some of the forces in the x direction, that's going to be 0 because it's not accelerating side to side. Forces to the right, minus forces to the left. And that's it, right? Again, I just got that by looking at my diagram. I have this blue force to the right that's horizontal. I got the force of friction, which is to the left. At this point, I'm going to go ahead and solve. So move force of friction to the other side. 200 cosine 30. So therefore, force of friction is equal to 173.2 newtons. Okay, next one. Now do the y direction. Sum of the forces in the y direction. And that's going to be equal to 0 as well. But now when I look at my diagram, I'm looking for all the up forces minus the down forces. So I should note that I have right two up forces, the normal force and the 200 sine 30, and then one down force. So that's going to be normal force positive because it's up, 200 sine 30 positive because it's up, minus the force of gravity. Of course, let's not forget force of gravity is equal to m times by g. So now to solve, we're going to solve for the normal force. So we're going to move everything to the other side. So that's going to give us mg minus 200 sine 30 is equal to normal force. Again, I just moved subtracted the 200 sine 30 to the other side and added the force of gravity, mg, to the other side. Now let's go ahead and plug in our numbers here. It is a 50 kilogram desk, so that's going to give me 50 times by 9.8, which is 490, minus 200 sine 30. We know that's 100. So that's going to give me 490 minus 100 force. So normal force is equal to 390. And that makes sense, right? It's less than the force of gravity. Force of gravity was 490. Normal force is 390. That makes sense because we're supporting 100 newtons of that weight. Okay, moving along to the next one. On this one, it's basically the same idea, except that we're pushing down on it. And so you could do the force diagram in a couple different ways, but I'm going to draw it so that we're pushing down kind of in that direction. We also have our force of gravity. We're actually going to have a larger force of normal force this time because it has to cancel out the force of gravity and your downward push. Also have force of friction. It doesn't matter if you flip the horizontal and vertical. Sorry, no, ignore that. It doesn't matter if you make it push to the right or push to the left. It's going to basically be the same thing. Of course, then we break it into its pieces. So we got our horizontal piece here. We have this will be 200 cosine 30, and we got our vertical 200 sine 30. Okay, so now basically same process. Some forces in the x direction still does not move, so that means our net force is equal to 0. Forces to the right minus forces to the left. Force of friction is equal to 200 cosine 30. So force of friction still equal to 173.2 newtons. In the y direction, sum of the forces in the y direction is equal to 0. Again, because we're not accelerating up and down, up forces minus the down forces. So in this case now, 200 sine 30 is now pointing downwards, so that's going to make it minus 200 sine 30 minus the force of friction, or force of gravity, sorry, minus force of gravity. Again, remembering that force of gravity is actually mg. So we add that to the other side, so we're going to get mg plus 200 sine 30 equal to normal force. Again, I've just added this to the 200 sine 30 to the other side, and I've added mg to the other side. That's why they're both positive now. I moved them to the side with 0. At this point, we go ahead and plug in everything. So we have 50 times by 9.8 plus 200 times by sine 30 is 100 newtons. Normal force, let's remember this is 490 plus 100. And that's going to tell us that the normal force is equal to 590 newtons. Again, that makes sense because since you're pushing down on the table, the normal force has to be greater to cancel out the force of gravity and also your downward push. So we would expect the normal force to be bigger than the force of gravity. Force of gravity was 490. Normal force is 590, showing that it's bigger. And we drew it bigger. We knew that going into this problem. Okay, I hope this helps you understand how to do these problems. Thanks for watching. Have a good day.